Hi there, I'm Dave McAllister. I'm the open source evangelist here at NGINX, and I'm going to actually talk about one of my favorite topics here, which are future things. Sort of what's coming next. We've seen a lot of changes happen over the last few years, actually even decades, that have changed the way that we have approached both our capability sets as well as how we build applications and manage our applications here. And most of this is driven around this increased complexity. We talk a lot about adaptive apps. We talk a lot about modern applications or cloud natives, but everybody is actually somewhere in the middle of the space here. Cloud is only part of this enabler of transformation. It's an investment that you're making into this environment. But quite often we see things that are moving from a place, a monolith type of place, through lift and shift, refactor to re-architecting these things. But by 2025, it's believed that about 85% will run somewhere in containers in production. But 2025 is still a few years away, 3 years, or in the old terms, that's 2 generations of microprocessors, given Moore's law, every 18 months. So what do we have that's coming next? Well, part of that increased complexity has resulted in a couple of different things here. And that increased complexity has shown us that we have a lot of different pieces that are fitting together. We've got Kubernetes in the background. We have the cloud environments. We have Java. We have all these different things here. At the same point in time, we have complications coming into play, how we are managing, delivering, and putting things together, while at the same point in time, we're getting a little chaotic. But fortunately, we have technology that's going to really help us. So let's take a look and dive into a couple of things. And we're going to start here with this space that I call modern applications or modern apps and delivery. We're all familiar with this. Microservices are near and dear topic to everybody's heart. We have lots of microservices architecture. And when we move into containers, we're quite often looking at microservices. It's important to recall that microservices are not as small as possible, but as small as necessary, where each microservice actually should do enough to do its complete job and becomes loosely coupled. And microservices have been around for a while, but the driving factor behind this, and I'm sure that most of y'all are connected with this, is something called Kubernetes, which is the container orchestration of choice by a mile. It is the winner in spite of this. Keep in mind that Kubernetes was actually only introduced in 2015. And so now it's about 95% of that orchestration marketplace. Because of that, Kubernetes itself has also gotten complex. And there are things that we need to look at that are important when we look at a Kubernetes space. The Kubernetes environments change from cloud to cloud. And so you need to understand what the changes are between those things, as well as where Kubernetes itself is evolving. And so we're looking at things that we're seeing more security aspects. We're seeing more capable systems come into play, be they from your laptop all the way up to a cloud environment like AWS or Azure or Google. So each of these pieces becomes important, but you need to keep your eye on where Kubernetes is going. Something that has definitely appeared and will continue to evolve is things such as service meshes. Microservices are tied together with a loosely coupled model. And that loosely coupled model gives us the ability to put things in place wherever we want to. Remember that chaotic structure? Chaotic structure, things come and go. Service meshes allow us to have that communication behind the scenes. And there are lots of them out there, including NGINX's own NGINX service mesh, that allow you to build these pieces so that your pieces can communicate with each other. Service meshes are going to be the heart of modern applications. We're already seeing this evolve, but over the next few years, service meshes are going to be the driving force behind those communication pathways. And then finally, inside of microservices, particularly when we start getting into Kubernetes and containers, is how do we get this stuff in place, or what's known as ingress? It can be a bit of a challenge to find the right place, make the right communications pathways happen. We've seen ingress controllers, Kubernetes ingress controller as an open source example here, that are really useful. They allow us to break into this space with almost no pain points. Now, there's always pain points, but now this one gets pretty close to being as painless as possible. Now, what can happen that you also need to think about is that this doesn't mean the entire world is going to change to do this. I showed you the migration paths a little earlier. And migration paths, as we move from monolith to lift and shift, sort of the same code on an environment, all the way down to other pieces, means that we have some challenges. And not everyone needs to rebuild everything in a microservices architecture. For that, we have app servers. Again, Microsoft Unit as an example here, a universal web app server that allows you to still use the cloud benefits, the ability to be elastic and scale and drive the functionalities while having complete and total control over all of your applications wherever they reside, independent of language. The other side that's kind of important for this is something near and dear to my heart, WebAssembly. You may or may not have heard of WebAssembly, but it's an assembly-like code and stack that lives inside of your browser. And this browser functionality means that it gives you the ability to send really complex applications into your browser with near native performance. WebAssembly is, in a sense, a cross-compilation target. You write in the language of choice, you deliver in this assembly-like language that allows you to put your code into your environments without having to worry about performance aspects here. The nice thing is it can run on the client, it can run on the server, and soon with something called WASI, Web Assembly Systems Interface, we expect to actually see it start driving native applications in an actual direct environment outside of the web environment here. That gives us some really cool things. So optimized code, API programming interfaces became a standard in 2019, and it's supported already by all of the major browsers. Where I'm seeing it used, we've seen it used for Adobe Photoshop runs it. We've seen other things that are using this, but we're also beginning to see it used in mobile edge environments, such as Cloudflare workers for this. The nice thing is WebAssembly could reinvent the independent game developer market by delivering performance aspects at near native speeds to a browser environment with all of the interfaces that we need. Now, the other side is that this is sort of a spin-off of JavaScript, and it doesn't replace JavaScript. JavaScript still does its job. What we find is that when we get really complex, JavaScript download times can be pretty intense. And so WebAssembly starts solving some of those activities that we can do this. So files in WASM, they are in low-level binary instruction sets, bytecode model. They have text versions so that you can actually read through it, a text available view of this, and give you this near native speed. WebAssembly is going to be our driving force for delivering applications, be they direct to the browser or be they through microservices connecting front end and back end in the future. This is one that you really need to pay some attention to. The other side of this, when we look at this complexity, is we have to be able to manage, optimize, and observe things. And that becomes really important, not just from a development viewpoint, but when we get into the running aspects of our application code here. We kind of start with this concept of observability. Observability gives us unique data from the inside of what's going on in our application that lets us understand what's driving that. However, in the past, we've seen a lot of things that have been separated. So observability kind of 1.0 had the three data classes, logs, metrics, and distributed traces, but they were separate. Fortunately, 2019, this initiative called OpenTelemetry started. And I suspect that most of you all have heard about OpenTelemetry. OpenTelemetry let us bring all of that data into a single telemetry stream so that we can now correlate that data all together. The reason OpenTelemetry is on my list of things that you need to watch for right now is that we are getting really close to having OpenTelemetry log formats be stable and ready to go. I believe they're currently in beta. I'm not sure, but at last I heard they're pretty close. But once this happens, we have a standard mechanism for data transmission as well as data format. Think of this as loosely as semantic context. We can expect certain classes of data to come in with certain things every which way. And that gives us some unique capabilities in its own right. And the first one of those, very honestly, is that it opens up an immense category for artificial intelligence or machine learning capability to drive forward new aspects, new capabilities, new automation, new responses, because we now have all the data all the time in a format that we don't have to worry about whether we're actually comparing things that make sense to each other. What happens is that because we now have all of this data, we can actually start looking at things like optimization. And optimization, we quite often look at how fast is the program running. But in an observability space, we actually are really worried about something I call the user happiness proxy. Because a user, very honestly, really only cares about kind of a couple of things. The request that they have just made and this request, success or failure, and how long it took. And when we start putting those together, that's where our optimization needs to happen. So that optimization piece becomes really important. And it's driven, again, through this ability to pull all the data streams together at the same point in time and see every single request individually, as well as seeing them on aggregate. However, we are talking about some downsides. There is a lot of data. We're coming in with logs, we're coming in with traces, we've got metrics in place. We may have hundreds of microservices driving us. We may have thousands of requests hitting us per second. And so we have a lot of data that's coming in here. Data is really important, but our data is only important as we can aggregate it, analyze it, and visualize it. And that again becomes really nice because OpenTelemetry as an open source project gives us the ability to tie to any structures that we would like to see backend wise, be they open source, a Jaeger, Zipkin, be they a commercial product offering. In any case, we can also make those changes. For OpenTelemetry, I'm also going to suggest you spend some time looking at the collector. The collector gives us the ability to bring in data, run it, what's called a receiver, bring it through the collector, and then export it in any format that we want. And that gives us this sort of amazing flexibility to not only support our existing applications and solutions, but also grow to applications and solutions in the future that make even more use of this data structure. The last thing that gets quite often talked about, and OpenTelemetry has been addressing this, is performance hits. If I'm collecting all this data, what does my performance look like? And so you also need to keep in mind that you're looking at what the performance impact could be in running an OpenTelemetry space. So OpenTelemetry is really, really an important thing in the future. If you are not into it, I suggest that you get in and understand what's going on. Traces are solid, metrics are solid, logs will be solid. And once we get those three streams together, the world of observing and optimizing becomes a major, major force for our applications as we move forward. The last piece is sort of management. And the management piece is important because we have that complexity that's coming into play here. We now have hybrid solutions. We have solutions that may be crossing clouds, multi-clouds. We have microservices that are appearing and disappearing. We have ephemerals, such as serverless functionalities. All these things coming in. We also have more complex technology driving those solutions. And we want to also track at the same point in time what could be a best practice functionality. What is the unique capabilities that I need to set up? What's a good starting point for my configuration guides? And so management is going to be moving towards more centralized points of contact so that we don't have to manage each piece individually. but we pull them together and we manage them from a centralized viewpoint. And we can see this in a single technology space, or we can see this crossing the infrastructure base, or both. The nice thing is that once you get into this and you have centralized management, you can actually have that management give you best practice suggestions or give you starting points that have worked in the past for other groups and other companies and other problems, and then be able to drive that forward. You can also see a hybrid support that's coming into play. And that hybrid support means that it's not just a cloud environment, but it can also be your on-premises environments at the same point in time. And it can be not only the infrastructure or the underlying platform, but the application and what's going on with the application. Within this, one of the problems is that we can see is an innate complexity. And this complexity extends to our applications and our technology space, but it can also now extend into our management space. The centralized management makes things easier, but not simpler. And interestingly enough, a gentleman that named Steve Newman, you may know Steve as the guy who created what became Google Docs for this, once made a statement: cloud environments make life easier, but not simpler. And the same rules apply when we now look at our own technologies, our own infrastructure, and our own applications. The abstractions that we're seeing make life easier, but the underlying structure is actually far more complex. It's WebAssembly. Very honestly, WebAssembly will change the way we approach creating and delivering our applications. The others are currently more or less in existence. And WebAssembly has been around. It started in 2015, but it is going to change the nature. It is changing the nature of how we deliver our applications, as well as the performance and complexity that we are allowed to have within our browser. And keep in mind, WebAssembly is already supported by every major browser that's out there. So it's probably already running in your desktop right here and right now. And then finally, a quick closing thought. And it's kind of a bit of a strange thought here, but back in 1979, Brian Kernighan wrote a book called Unix for Beginners. And in there is one of my favorite quotes of all time. The most effective debugging tool is still careful thought, coupled with judiciously placed print statements. What we are seeing is that while it may not be purely a debugging tool, it may be a management tool, it may be an optimization, it may be an automation tool. What we are seeing is that the same rules apply. Technology is only as useful as you make use of it. And with that, I'd like to say thanks for listening and have a great time. If they've got questions, feel free to send them my way.